start? Okay. Yeah. Where's the organizer? Okay. Good afternoon, everyone, and welcome to our session on policy and standards. I am Tatiana Pasquel Garcia from Vito Energyville, and I'll be the chairperson for today. I'll give a brief introduction of what Vito Energyville does, which is my institution. We are an umbrella organization that gathers Vito, the Flemish Institute for Technological Research, the University of Leuven, IMEC, and the University of Hasselt. We have 300 researchers located in Limburg, Belgium, and we develop new technologies, knowledge, and methodologies, and new products for the built environment and energy in general. We are a research center, and I'm here proudly with more of my colleagues, and they'll be presenting as well. These are the topics that we're working on currently, and in the framework of this session, although we are a technology center, policy and standards for us are of major importance, especially in the built environment, considering 33% of the carbon emissions in the world come from the built environment. 80% of the global energy use is consumed in cities, and by 2050, most of us will be living in cities. Taking into account these numbers and the challenges that have been posed into this generation on keeping our temperatures below 1.5, as the IPCC report indicated a couple of weeks ago. In this session, we'll be exploring how policy and standards can help us either tackle these issues, what are the hindrances that also bring, and exploring from European policies for smart buildings to the need of standards globally, and also what are the opportunities that lack of regulation and free regulation zones can bring to come up with innovative business models for the built environment. That's what we do at Energyville. That's where we aim to convey here, and I'm happy to say that the organization of the European Utility Week this year has brought a very nice assemble of speakers. I'll present now our first speaker. He is, well, that's me, thanks. Our first speaker is Frederik Lux from Flux 50, a Flemish-Belgian initiative, and he'll be presenting a very nice project that will take place in Brussels.
Thank you. During the next 15-20 minutes, I will take you around to a research area. Actually, it's a business area near Brussels, where we are trying to create a large-scale microgrid, combination of a thermal and electrical microgrid. But perhaps as a start, let's present myself and what we are doing as Flux 50. Actually, as Flux 50, we are a cluster organization. So we are trying to bring companies together in order to realize such large-scale projects, because those large-scale projects, they don't appear out of the blue. They don't exist from themselves. Often there is the need for a facilitator who is trying to bring all those parties together, and even more than bring those parties to the legislation, to the regulator, to the DSO, and helps them really talking the kind of language that the regulator, that a policymaker understands, because what we see is that there is quite a large gap between, on one hand, what the industry is bringing and what industry is trying to create and to conceive, and on the other hand, what policymakers are trying to achieve. So a large part of our job is also trying to bridge that gap between regulation and industry and prepare the regulation for the next step that will come with the industrial products that are in the drawing schemes and that are perhaps even at lab stage. So what we do is we bring those people together, we orchestrate. We are not one of the people who are creating technology ourselves. We let other people play and let other people create that technology, and we help them on bringing that into market. Our values, we are financed partly by members. We are a membership organization. We are partly paid also by our Ministry of Innovation. So our goals are rather economic, But we do believe that if we want to achieve those economic goals, we need also to take into account the ecological point of view. So, but we are not measured in tons CO2 that we don't emit, but we are measured in additional turnover, in additional employment at our member companies. Just a little bit about ourselves. And one of the projects that we are quite busy with is actually an area, a ground area. At this moment it's empty space, which is located quite near to Brussels. Just to give you an idea. Just to give an idea, the red circle is already Brussels, and the green circle is Flemish region. So if you want to see how different legislations or different regulation can prohibit things happening in a single country, you can see here a very good example of that. Just to give you an idea, the aim is to have at that empty space, to have there a data center which is powered by 5 megawatts of solar power and by 9 megawatts of wind power, and reuse all the excess electricity for those 71 companies which are already on the research park, and to use the excess heat, the waste heat, to have the heat provided to the companies on that stretch of the business park. In the beginning, we had also the aim to have excess energy flowing to the Brussels Health Campus, which is actually the university hospital. But because we needed to bridge that border between Brussels and the Flemish region, we stumbled into a lot of regional policy making that really disabled the option to do that. For example, the local DSO is a different one. And when the electricity is generated in the area of one DSO, he is able to oppose that we transmit it to another DSO. Yeah, so the Brussels area has a DSO called Sibelga. He was willing to take the power, but our local DSO, which is called Fluvius, simply opposed. We were not able to do that energy transfer. So we were looking for other ways to go with that. And when you take a look at creating such a large project, you first begin to see what is feasible and what you dare to do. And in this sense, we brought along, I think it was around 24 companies, which were investigating each their part of the total puzzle. So you can see here that we had 6 different feasibility studies. It were small scale, half year, 1 year studies on the business models, in which we also investigated what is hindering us. So what regulation is hindering us, what tarification is hindering us, so that we could bring that learnings as a whole to our policymakers. Next to that, letting companies collaborate seems easy, but it's not always that easy. Yeah? So when I was saying that we had 25 companies collaborating over there, all with their different backgrounds, all with their different IP, a lot of the things that we really were doing in those feasibility studies was creating trust amongst the companies. Trust that it was feasible to create such thing, trust that they were in each other's capabilities, that together they were able to realize such a large system. In total, we had 6 different focus points. Of course, the CO2 neutral microgrid, which is totally into electricity, combined with a thermal grid. And there is a large balancing possibility from changing electricity surplus into heat surplus and vice versa. So we are also investigating that coupling between both of thermal and electrical grid. Of course, we have the green data center, because we have there the willing to have the data center of the University of Brussels located over there, together with some other data center capabilities. And in total, that data center is using around 3 megawatts of electricity on average. And it is producing around 2.8 megawatts of heat production on average. And of course, we are also able there to balance a little bit. We are able to balance there a little bit between what the consumption at a certain moment in time. And of course, the data center, when you are able to make it more efficient. I think that one of the next speakers will speak about the DC in data centers. Well, if you are able to make more efficient use of that electricity need in the data center, it's of course also very, very useful. In order to have the grid, to stabilize the grid, to do the long-term, the short-term storage, we investigated battery to grid, but we also investigated vehicle to grid operation. Just to let you know, only 1 kilometer away from this stretch of land, we have one of the large highways going into Brussels where there is always a traffic jam. And when we talk about traffic jam in Brussels, I don't know who has already been in Brussels, but when we talk about traffic jam, we mean traffic jam. So you can do half an hour there over a stretch of only 5-6 kilometers. So one of the aims of the Brussels Health Campus is also to have a lot of people, their employees, parking their car over there, using it to stabilize the grid, and then use electric vehicles like electric bikes and those kind of things to use the bicycle path which is just passing by to travel at last 600 meters to the campus. So that's the reason why vehicle to grid is quite an important aspect in the total of the Green Energy Park. Not one out, but because it's linked to the university hospital, I don't think it's that weird, is the surgery room. So we are also looking at how can we make a surgery room more energy efficient. Just to let you know, the emergency quarter of the hospital is daily using as much energy as one household on a yearly basis. So if we can have there better ventilation aspects, have better use of the pumps and those kind of things, we expect that we are able to cut there the electricity consumption with around a quarter of the current situation. So those types of feasibility studies were mainly done with two aims. Really look at, is it feasible, and bring that feasibility to the policymakers in order to engage them, to have their commitment in order to really sustain this project. And of course that's only part of the puzzle. We also have consumers. We have those 71 companies that are there on the research area. We also need to convince them that it's useful to participate in such a community, in such a local energy community. And what's the best way to do that? The best way to do is to throw a party. So what you see here is a tent that is really standing on that stretch that we had over there in the previous slide, where we informed as well policymakers, as well companies, as well the companies on the site on what we were, or what the Green Energy Park is willing to do, and that really proved very useful. It provided some ample discussion room. We were able to give in a very focused way, get feedback on what the meaning, the feeling was of the companies there, what their drawbacks were. We were able to take them along in the next steps of realizing really the grid. And moreover, if you also give the floor there to the local policymakers, this is the mayor, for example, they also buy into it. Yeah, actually, as you can see, there is such a stretch of grassland. The mayor really had the local bus company. They engaged them to bring all the guests to the premises and vice versa. So we were having there the local mayor, we had the Minister of Innovation, we had the Minister of Energy, we had a video message of Šefčovič, Vice President Climate of the European Commission. We had different high-level people of the University of Brussels, of the University Hospital, and that created a lot of commitment. What we were able to do there was creating a feeling of there is no way back. Yeah? And that was very important to realize this. Because when we are talking about creating microgrids, when we are talking about bringing things to the large public, we are often thinking about research and development. Yeah? And that's where we are stuck as technicians. And what we really want to do there is we want to extend it with a living lab, with a showcase where other companies are able to see what is happening and also to be able to test drive their technology in a real-life case. And moreover, not only technology, we also want to provide there a stretch of land in which we're able to test new policies, new tariff structures, also in a real-life setting. So we are trying to convince our government to have there a stretch of regulatory-free movement, in order to be able to test drive new forms of legislation. I will come back to that later on, but what is really essential in having that is having all stakeholders on board. We are not able to do that without the cooperation of the local DSO, Fluvius, which seems easy, but which is not at all easy. The stakes that are driving a local DSO are simply and often in contradiction with just the feeling of a local energy community. But still, we were able to let those people talk to each other, and you can now see that, for example, local DSO is one of the one of the partners which is really in the heart of that research and development and really in the heart of that living lab and showcasing. But what we often forget is that showing technology is not enough. What we want as company, as cluster organization, as companies, what we want is to have that next steps. We don't want to have to achieve this only in this specific premises, in this specific site. We want to be able to have that same kind of technology exploited all over Flanders, all over the world. So also education and training is one of the things that we really want to engage a lot in that stretch of land over there. Because we do feel that when there is no, the technique installation guys are not able to install those techniques, when the surgeons are not able to use those new kinds of surgery rooms, we will never get to that point what we want to achieve, being creating economical value for the companies which are behind it. So we are really also busy with creating a marketing logo, a brand amongst it. On one hand, on that green energy system, and on the other hand, on that green medtech system, both located at the same time, at the same place. So when we look at the stretch, we are looking at 4 different towers, but we're also looking at the hotel, because we do see that there is a lot of willingness to use that surgery rooms also from abroad, and if you want to have people from abroad flying in, you need to have some accommodation for them. So we are talking about a hotel, we are talking about a virtual reality training center in which we are able to test drive those new techniques. We are talking about an education center, we are talking about an experience center in which we can have the local students, both primary and secondary school, really experience what energies, what climate transition can mean to them. So we want to have there on that stretch of land, on that business park, we want to expand it to not only a microgrid, but to really to have a demonstration field, an experience center on climate transition and local energy. And also to have our politicians be made aware that we can do that in Belgium, in Flanders, which is also not something that they are very, they didn't know that actually. But of course, when you have when you want to realize something like this, you need to know, you need to see also that you can have that regulation imposed later on. And what is the best way to have that regulation imposed later on in Flanders? To our belief, that is really testing new legislation, new tariff structures in a real-life environment and engaging as much of the stakeholders as possible. So at this moment we are realizing a large-scale cooperation project with in total 25 partners, and we engaged a lot of different kind of partners. So there are of course research organizations behind, like Vito, like KU Leuven, but we also involved the DSO, and actually he's willing to make quite some investments into that area. We engaged 4 different legal organizations. For our Minister of Innovation, that was something completely different. Why do you need legislation? Well, a lot of energy transition is hindered by legislation, so we are trying to convince them that we also need to sustain those legal companies to know what is happening to them when the clean energy package is coming to them, and to also prepare it and to prepare legislation in such a way that when the politicians are creating something, that it's not immediately mitigated by what the legal councils are trying to do. We have of course 5 engineering companies, 5 control companies, 4 ESCOs, 5 operational services companies. And why do we have that much of different stakeholders in there? Because we are really trying not to test drive that new legislation into one specific situation, but we're trying to test drive that new legislation in different contexts. So not only in its research park, but also in a new to-be-built district, a greenfield. We want to test drive that new set of legislation in a residential area where they have a lot of problems with power quality because they're located quite far from the transformer station. We want to test drive that same type of legislation into the apartment buildings. And it's only by combining all those different insights in one project and having an umbrella view over all those different ways that legislation can change the uptake of renewable energy, the uptake of green electricity, that you're able to make a convincing story to the policy makers and also to the regulator. The regulator in Flanders, he was not willing to be part of advisory boards for the last 3 years in projects because he was saying, okay, I'm always putting somebody before then and I cannot be in 10 projects at the same time. Well, because we had that large stakeholder group here behind, he was able to say, okay, I can engage in a stakeholder group because I can talk about everybody and I can get the views of everybody together. So it's not about realization here, it's about really getting the data, getting the tariff structure, getting the legislation right. And in total, the project is budgeted at around 10 million euros. And we are aiming at around 6 million euros of different government grants for this one. We hope to have it approved by the end of this year, so we are keeping our fingers crossed. We are doing our best to be here, let's say, within 1 or 2 years to show you the results of this large scale project. And what is really the aim of it? It's really modeling a local energy community. As I said, it's not about realization. Realization is inside different other projects, infrastructure projects. Here we are modeling local energy communities. And not only modeling them, we're also taking a look at, is the model realistic? Is the real life situation going in the same line as the model? So we are having key performance indicators that we will be able to see at the end of the project, are we able to achieve them in real life operation? We are going to take a look at legal aspects, the roles of the different people. What is the role of a DSO in such a local energy community? Also GDPR-wise, what about freedom to choose for your electricity provider? So all those kind of things we will take into account. We will take a look at the dimensioning of a local energy community. How much renewable energy do you really need? How much storage do you really need? Do the simulations coincide with the actual situation? In order to optimize the total cost of ownership of such a solution. We are also there taking a look at, let's say, something which we call energy syndicates, which we say that there will be somebody who is taking care of the whole energy production, who will manage the energy production, and who will then, in a later stage, sell the electricity, the energy as a service to the companies. And of course, we hope that it will have some impact on the energy system, and we are also willing to see what that impact is, as well on the distribution system, as well as on the transmission system level. When we're talking about regulation, what we see that it's not only about regulation, we are focusing a lot on legislation, but when we calculate business cases, we do see a lot of problems with tariffication also. I don't know what the situation is all over Europe, but in Flanders we do have the largest distribution system cost, which is just put on top of that cheap or not cheap energy production. There is a large societal debate on when we do local energy communities, when we are really going for that local production and we are not branched to the electricity grid anymore, how will that distribution system, that the societal value be distributed amongst the other parties which are not part of such a local energy community. So we need to take into account that kind of societal values also, which are typically reflected rather in the tariff structure instead of in regulation aspects. And of course, last but not least, we also want to see how we can engage that end user, how we can change that behavior of that end user in order to really use energy at the time when it's available and really tap into the system and make them energy savvy, make them energy responsible instead of just energy consumers. And with that, I came to the end of my presentation. The only thing I can still do is invite you at the Belgian Beer Cafe. within a few years we will be renowned for our energy systems, but at this moment we are known for our beer and our chocolates. So at 4 p.m. this afternoon, and also 4 p.m. tomorrow and the day after, I think, we will have our Belgian Beer Café at our booth in Hall B, B20. And of course, you're all kindly invited to join us there and to have a little chat amongst all those nice topics within a fine glass of beer. Thank you.
Thank you, Frederik. Can everybody hear me? Because I feel very strange going like this. And it's bad for my back. So can everybody hear me? I don't have to go. Okay, perfect. Does anybody have questions for Frederik? Questions? No? Okay, I have one comment. If I can, sorry. What are you looking for? If I can sort of wrap up your presentation in a couple of phrases. What you're advocating is for a free regulation zone to enable a living lab to later get a proper regulation for replicability and scaling up of these new technologies and new innovative business models and so on. But for this, you need the engagement of your major stakeholders. I can pinpoint you to somebody from Sibelga sitting on the, on the audience, if that helps. Sibelga is it's one of the utilities in Brussels where the project takes part of it. But I was wondering if this is an appropriate way to wrap up your presentation.
Yes, it is. And as I said, we had a discussion with Sibelga because we wanted to go, at first stage, we want to go to Brussels. But then Freeview said, okay, you're not allowed to do so because we have the first right of refusal, to call it like this. And yeah, it's really about getting all those stakeholders on board, knowing what they are looking for, and also from time to time on just doing it. If, for example, in Flanders you want to have the politicians to move, you can wait for ages, or you can just go further and put them against the block and say, okay, now I need that regulatory free zone. You're not going to kill a project of this size with this feasibility, in which we're able to let the Vice President of Climate of the European Commission say, we need it, we want to have those lessons learned. You are not going to kill it. And actually that helps to put some politicians in front of their responsibilities.
Well, thank you very much, Frederik. Our next speaker, it's one of my colleagues. It's Joran, and sadly his presentation title is not here, but you can see it in a couple of seconds. So he'll be talking about standards and how these are favoring or blocking new energy technologies.
Okay, good afternoon, everybody. You can all hear me very well? No, not really. If you get a headphone, it works fine. Okay. Okay, so now let's get a bit more technical than the previous speaker. Nobody's running away? Okay, that's good. Because I'm going to talk about how standards and grid codes and other kinds of policy measures are interacting with technology and innovation. And why do we have to look at that? Well, of course, the energy transition is happening. And what is happening, I guess you all know that. I don't have to repeat all of this, because otherwise you wouldn't be here if you didn't know this. We see this energy transition towards more sustainable energy. And in practice for our cities, this means that we are going to introduce much more things like HVAC, heat pumps, electric mobility, photovoltaics on the buildings, storage to balance it out, and also some smart loads. And how do we manage that? Well, we've got all these digital technologies, and you can find them all around here on this nice exposition. But that's on city level. What happens on building level? If you go down one level at the building, we can see that there the consumption of electricity is always rising, despite the fact that we are introducing much more energy efficient technologies. Think of LED lights. Well, LED lights, they save power, but we've got a lot of rebound effects and a lot of new technologies coming alongside it, like IT, and they increase power consumption. But luckily, at the same time, our buildings are becoming also energy generators, mainly because of photovoltaics. And that was mainly, at this point, situated on the roof. but to balance out demand and local production, especially if you're living in a country that favors self-consumption of that locally produced energy, you have to introduce usually a bit of batteries to balance out that nice solar power. So, if we, how will this continue? Well, we anticipate that from now on, also that part of PV will be increasing even more, because the roofs are all covered, and what's the next side of the building? Well, we go to the facades, we will go to the windows. So BIPV will be the next step. But that made us think, well, we try to put that in that classical electrical grid that you have inside your house. But that's still the right way to do it? Because now we have to put a lot of technology on the outside of your building, where you've got no cabling, there are no sockets there where you can just plug in your devices. So that made us think how to do that. And also, we need to do that in a very reliable way. Because if you talk to people who work in construction, they want these BIPV elements and all the converters that come with it, they want them to live for 30 to 40 years. Whereas for the moment you're happy if you can make 20 years with your current PV installation. But 30 to 40 years, that means 100,000 hours of operation. And that's a magical number in electrical power, because that is actually the goal. If you design for aerospace, if you design something for NASA or ESA, that's what they ask you. But here you have to design it for the mass market. So we've got a lot of work to do. Now, how will we connect all that new technology? Are we going to stick with those classical sockets? Well, maybe not. Because let's look at the PV and battery combinations. There are several options. Now, I cannot use my pointer, unfortunately. Lasers don't work on these smart screens. But if you look at the upper left, you see the classical way to interconnect everything is with AC systems, your classical sockets. And we are doing that already for many years, actually already for more than a century in practice. And then we add a bit of batteries to it, go down one, and we add a bit of batteries for balancing. You can do that on the AC side or on the DC side, and you can get some special converters to do that. But actually, we have so many DC technologies inside that system. Think again of those LEDs, charging vehicles, IT power supplies. They are actually all DC technologies. So why don't we just connect them all at the DC side, and maybe we don't need the AC side anymore. So that is a story that goes on in the electrical world already for, let's say, 20 years or so, more or less since I was a student myself. But up till now, it never made sense because the technology wasn't there. Although in some niche markets you can see it happening. Think of the data centers. If Google and Facebook build a new, or Amazon build a new data center, they don't put in AC anymore, they put it in DC. All the computers get a DC power supply. And if we go to buildings and the public lighting, with all the LED, you see some experiments happening where they use DC cabling for the street lighting. So they start skipping AC there. And even in the industry, if you, this is for instance a picture from a Mercedes factory where you've got all these production cells with the robots. Well, they're all coupled on DC with some storage locally these days. And if you go off-grid, far away from the main grid, DC is also very natural to do. And if you even go further away in mobility, they don't care about 50 or 60 hertz if you're inside an airplane. So there also DC is these days also a first choice. But why aren't we doing that everywhere? Well, that's because of what happened between these guys more than a century ago. 120 years ago, these two guys had an argument. The left one is Mr. Thomas Edison. He invented, or should I say, bought the light bulb from an inventor. And he had a chicken and egg problem, so he also had to start the first electricity company, Edison Electric and later General Electric, companies that still exist. But he couldn't get very far with his DC electricity. So that's why one of his former collaborators, Nikola Tesla, they had an argument, so he left and he said, I can do better. With the money of Westinghouse, he started AC grids. And that became a technology lock-in of the 20th century. Why do we do AC? Because we're so used to it and we think there's no alternative. Although there is an alternative. You can make a DC grid, and you all do that all the time. I guess you all have a laptop and a power supply. Well, if you charge up your laptop, you make a small, pointer doesn't work, you have to learn that. If you make a power supply for a laptop, you make a small unipolar DC grid. Especially if you do it with USB-C these days, and you also use that to charge your iPads, etc. So that's unipolar, and they do the same in LED lighting. But there's an alternative. You can also make a bipolar grid. So a plus and a minus, and if you want a zero line in the middle, that is something that could fit higher powers. That's sort of the equivalent of single phase and three-phase AC power, but this is the DC version of it. Now, is this just an invention of mine? No, actually IEC, because I have to talk about standardization here at some point. Now IEC is actually already looking at this. They predict that this is electricity for the 21st century, and they propose many alternatives, and they also say that there's an urgent need for standardization at this level. Because a lot of things are happening, like a standard for LED, a standard for USB-C, but the moment you go to bigger buildings, everybody is trying different voltages, different types of cabling, and if we don't watch out, we end up again with a big chaos. So, now that's the technical side of the story. Does it also make sense from a financial side of a study? Because up till now you get the engineers interested. Now you also have to get the investors interested. Well, we made some simulations and designs, pre-designs for big buildings, where we compared AC cabling case, AC conversion case, and DC conversion case. Now, AC is of course the benchmark, and unipolar DC is actually a little bit more expensive. Ouch. But bipolar is cheaper, we found out, because you can have relatively high voltages in there, plus and minus, double voltage. So that means simpler cabling, lighter cabling, and especially if you start introducing storage at the right places, you start making money. So if we looked at the results of these simulations, everybody knows that if you skip all these AC-DC conversions, you will save some energy conversion losses. That's clear. But that's only 5%. Why? Well, all those power converters you've got, all those USB chargers, that's not rubbish either. That's good stuff. So you only save 5%. That doesn't pay off your switch to DC. What pays it off is the fact that you can save 30 to 35% of investment costs in the end, because you can skip a lot of that power electronics. And that power electronics is relatively unreliable. All those AC-DC converters, they once in a while break down. So you save also some costs there. And that is when you start making your business case. But why don't we do this all the time? 35% investment savings, you won't leave that. Now, why don't we do that? Well, if you try to build the building like that, you quickly discovered that all the technology is not out there yet. You find some DC technology, it mainly comes from railway applications and so, but if you look at typical building specific things like protection, differential protection, converters to integrate that photovoltaics, you find a lot of these components are at a very low TRL level. So that's why we decided in our research center to develop the missing components and try to put that in our own building. Because we were building, by coincidence, a new building 2 years ago, and we said, let's try to make part of that building in DC and prove that we can do it. So we wanted to show that we can make a living lab and get it safety approved according to the codes that are necessary. And here we come again at standards and policy development. If you want to do that, you quickly discover there are no safety rules for DC. There is indeed no standardization, so how the hell can you buy stuff that is interoperable? Well, we try to solve that. This is to get the engineers interested. We made a very interesting cable layout so that we could emulate all kinds of DC grids, bipolar, unipolar, all the way up to high voltages and low voltage. But this is nice that you can design something like this and make all the power converters for that and hook up your PV and chargers of the vehicles. But in the end, somebody needs to come and give it a safety approval, and that's typically for Belgium, but there's other European countries working like that. We are allowed to mess up our own grids, but in the end an independent body has to approve it, and then you can switch it on and use it publicly. In countries like Germany, only certain technicians are allowed to work on the grid. Well, we have a bit more freedom, but in the end we had to get a safety approval, and you had to get it in a country where you only have AC codes. So we had to go back to the basics of what is under that code, the rationale, look at existing international standardization that is being developed and build up a legal case that way. So we ended up as engineers doing legal research. And in the end, we gave our legal case to the approval body and they approved it. Maybe they didn't dare to disapprove it if we said it, that it was right. But in the end, we got our green stamp on it. So that makes us the only existing low voltage DC microgrid or nanogrid, no matter how you call it, that is reconfigurable in the country of Belgium. It's 100 kilowatts. We can test up to plus minus 500 volts, and it's safe. Now, are we unique? Well, we checked around. There are 20 installations like that in the world, of which 17 are unipolar and small, and only 2 others and us are the big ones, the bipolar ones. So we think we have a quite unique setting for the moment. But to conclude, now this was mainly a very interesting journey from a technical point of view, and I explained you why we did it. Because of this energy transition, if you go all the way into the buildings behind the meter, you also have to think of the technological consequences. And we ended up rethinking everything that became a legacy AC system in the past, and we came up with a totally new kind of electricity system, what we call a DC nanogrid inside the building. And that is clearly cheaper and offers a more reliable implementation. But the problem was, we are behind with the standardization, behind with the safety codes. So to get it safely installed and don't get the lawyers too interested in it, we managed to get it approved. But I would plead to develop as quickly as possible also standardization and new codes for DC installations, because otherwise we have the risk that we will get behind other continents with this technology and also miss some very good and interesting opportunities to make electricity more sustainable in the city and buildings environment. Now, there is already an onset of international initiatives, but unfortunately I have to tell you that a lot of countries try to do their own thing, so we already have differences between the IDs in the Netherlands and the IDs in Germany and in Belgium. We don't know what to choose among them, so we urgently have to come up with international standardization, and in that way we can achieve also the famous interoperability holy grail that we urgently need in smart technology. Thank you very much. Yeah, if you want to know more about that, you grab a beer at the Flux 50 stand and then come to us.
Thank you, Johan.
Yeah.
Any questions for Johan? This was a little bit more technical than the other speakers, but I think the take on us is, well, Johan is a very big advocate for standards, and I think he made a very interesting point on my favorite on these presentations. Because I work in a research institute surrounded by lots of engineers, I really like it when they come down to earth and they put it in numeric business numbers, because if it doesn't make sense in the business world, then what are we talking about? So I really appreciate that part. But to continue from the very big advocacy to a low regulation zone, no regulation zone, to let's get standards to get this going, and globally, we need to understand our consumers as well, because if we don't understand our consumers, doesn't matter what policies or standards we have, it's just not going to work. So with this brief introduction, I want to welcome Friedrich from Iceland, who'll present about branding.
Hello there. Always when I speak at these, I'm the different guy, so I'm going to speak about something different. And I was asked to talk about policy and regulation. It's not really what I do, but as was said here previously, you can't make regulations and policies if they are counterintuitive and people just don't like them. So I'm just going to walk you through some of the stuff that I've done. This is about myself. I run a consultancy and I work for retailers around the world. And I am a professor at the University of Iceland, and I also host a conference that's only for energy companies and how they communicate. So, and if you want to talk to me about any of these afterwards, you're welcome to. So what is energy branding? I came up with this concept 3 years ago to kind of encapture how you talk about energy differently than you would from Coca-Cola or chocolate or whatever else. So I'm going to explain that if you want to be a brand, you must be different. So as I told you, I'm always the black sheep almost, because I'm saying different stuff from the rest of the guys here, but you have to be different. But for utilities, that's sometimes hard. They don't dare to be different. So these are logos. To many people, a brand is a logo. A logo is only a small part of a brand. It's what images that you put into the logo that matters, not the logo itself. And when you look at this slide, you see a lot of fantastic German cars. When you look at them, something happens in your minds. Someone might look at Porsche and think something. Someone might look at Audi and think something. But those things have more or less been planted in your minds. You've been told what to think, if you will. So that's what a logo does. And this is a circle of what an energy brand is. It's a lot of different things. It's not about the logo, not about the marketing. It's a holistic thing of how you approach consumers, but not only consumers, but also regulators, also B2B, also governments. So that's where I'm coming at. You approach the thing in a different way. So what I was thinking, what should my angle be when I speak here today? It's about policy and regulations. What should my angle be? I figured, okay, I'll talk about use the sustainability, or I'll talk about green. But those concepts are very ambiguous, and I put love there. Although green is as ambiguous as love or happiness. That's what I write, because these things can mean so many different things. So if you want to regulate those things, you have to really understand what they should be about. So I don't know, I'm Icelandic and we read a lot of Nordic literature. Do any of you know a book by Ole Lund Kierkegaard called Robert Tassin? No, maybe there was not a good case, but that guy was dyslexic and he couldn't really understand his school books. And when he was reading the books, the letters just jumped out. It just jumped out of the pages. He didn't understand anything. When I entered the energy space 3 years ago, I felt like that guy. I just did not understand a word. In my very first conference, it was a very technical thing, and I thought either I'm very dumb or they are speaking a different language here that I don't know. But maybe it's both cases, but we use a very intrinsic language. People don't understand us. We use an intrinsic language that we understand, but we have to deal with consumers at one point. So they have to understand us. So this is Gumi Tassin, Robert Tassin. So when you talk about setting standards and setting benchmark, talk about green, for example, you have to answer a lot of questions. And these are some of them. Which environmental benchmarks should be chosen? How should environmental impacts be factored in? Does green power need to be totally green to be sold to consumers, or simply greener than the next guy, etc.? There's a lot of different things that you have to factor in. So if you want to set a regulation, we have to find out what exactly are we talking about. I had a client that came to us and they wanted to promote their green sources, but they had a really big issue of choosing the word to use. They produce green energy. So should they say clean energy, green energy, pure, renewable, sustainable? So, but just by the raise of hand, do all these factor into what is green? Well, it's a difficult question. Consumers don't know the difference. So if you want to have a successful regulation, we have to speak the consumer's language. We can set regulation, we can force people to be green, sustainable, whatever, but if we add a layer of branding on top of it, we understand them better. So what's the difference? Renewable, green, sustainable, clean. There are a lot of various definitions, and if you talk to a technical person, they'll tell you what green is. If you talk to a normal person, they tell you something else. So these slides will be available to you afterwards, so I'm going to go fast through them. So this is, for example, from the US. If you talk sustainable, you talk green, there's a lot of variations of what it is. So what are we talking about here? this is a model that I made myself. My task, when I set out to write a PhD about energy branding, I wanted to learn how is the energy consumer different in some way from the rest. And I wanted to see if they think differently. And normally I move around a lot, so I would walk, but I'm stuck with this thing here. So if you want to promote green efficiently, you have to do it from the consumer's point. Then you have to take into account all the different factors that matter. Oh, it doesn't. Anyway, so if you want to do it sustainably and into the future do it correctly, you have to think, I have to move now. Can you hear me properly here, like this? No, I have to stay here. Anyway, okay. Yeah. Can you hear me properly now? Oh, I'll have to stay here. No, here it is. Okay, now it's good. Okay. I'm talking about this from a branding perspective, of course. Well, the same applies for regulators. If you want to be understood, you have to do it from the consumer's perspective. And you have to understand how liberalization, how energy is different from others. It has, the liberalization has an effect. It clouds our mind, and people are very skeptical towards it. And it has a commodity qualities. So it's not like Coca-Cola or a car that I can touch. I showed you cars earlier, but cars are actually the easiest thing in the world to brand because there's so many things you can meddle with. And also it has a really high critical environmental impact, so we have to take care of that as well. So going through this, let me just, I'll skip a little bit through here. So trying to figure out what green is, I did a research in 5 different countries to see what is green. And obviously I found out that green is not one thing, it's various things, it's many things actually. And these are factors that consumers considered green to be. There's a lot of factors on here. And if I go on this side here, so price obviously is an issue, it's more expensive. And the black boxes mean it was found in all the countries, but this box means it must be always found like to a smaller extent. So green was mostly associated with skepticism. It's a marketing trick, someone to take our money. So it's about trust, politics, artificial hypocrisy, concerns of the Western countries. It's not really positive, but if you want to promote green, you have to overcome these obstacles. You have to understand how they affect the consumer's mind. Green is marketing, sustainability, CSR. People don't really understand the difference between sustainability, corporate social responsibility, or renewable energy. So we have to understand these. The visual impact was scored really high. And it's about saving, it's a lot of things. And nuclear energy is, just by a raise of hand, is nuclear energy green? Just raise of hands. Well, some people think. How many think nuclear energy is not at all green? A little bit more hands. But how is that possible? I'm assuming you're smart people. I'm assuming that you understand nuclear, but you don't agree. Because that's just the very definition of branding and marketing. People have different ideas about things. If you're a regulator, you're a policymaker, you have to understand whom you're talking to. You can force people to do stuff, but you're much better off if you go with the flow, if you will. And for example, in the Czech Republic, they considered nuclear to be really green. You know why? Because they remember the time when they had a hard time breathing. Because coal plants. So obviously, something that replaces that and you can actually breathe is nicer. So this is just to show you. I mean, if you're a regulator, pay mind to this. So I made this into a centric framework of how you. What I wanted to find out is how, as a consumer-centric definition of green. And it takes into account all these factors here: skepticism, marketing, identical nature, and also the other factors. These are impacting, these are defining. I'm trying not to be too technical, so I'll go fast through this. Anyway, so basic thing, you must understand the customer and not show them stuff like this. This is for technical guys. This is my theoretical framework, and I'm just going to do this. I don't want to dwell on it because it doesn't matter what I think, it matters what the consumers think. So we have to understand what consumers think. That's why you have to measure. And in marketing, and I'm coming from a marketing perspective, then we can spend a lot of money on marketing. And this is a famous quote by this guy. And he was asked, how much do you, well, he said, half the money I spend on advertising is wasted. The trouble is, I don't know which half. And this is actually, in actuality, a lot of the utilities in particular, they are just pouring money to try to fix their image, but they don't go back and look at how the consumer actually thinks. So we have to measure, and these are the basis of a good brand. You have to be different, you have to segment, and if you think about your image and perception, otherwise you can't be a good brand. You have to measure those factors to be able to, to carve your niche. And what we've done at my company, we've analyzed which factors are relevant, and all of these, we have several factors measuring each one of these. We put this in a model, or this is actually just a weighted average formula, but we've calibrated it to give out a number. So now we know how if you do this test, we know how much you score, how good you are as a brand. And if you score 70, you're okay, but still it's not good. On a scale from 1 to 10, you want to score 9 and above. Because if you score 9 and above, then customer churn is lower. And we are less price sensitive. We are less willing to go for the lowest offer. So we really want to measure ourselves as brands for us to be able to, take part in the future game. So, and we also measure, which markets have the green brands. And I think you can agree with me that Norway is a pretty green place, right? Do you think Norway is a green country? What do you think? Yeah, many think, and then they are, but consumer perception is not the same thing. They are not considered to be really green. 2 minutes. Okay, by their standards. And I'm just finishing up. So we have really important things like this here, but we also measure things that are less, like Norway is also the least fun market. If you know, are there any Norwegians here? No, but they're not very funny. So it doesn't surprise that they are measured low. So just to finish up, we want to know how relevant we are to the consumer, and we measure how what they think about us. And when we think about incumbent brands, most of us, this is what we think of. We don't really think anything at all. It's generic. Some things positive, some things are negative. But if we are building a brand, we want people to have an opinion on us. So these are cases of what people say about incumbent brands. There's nothing comes to mind, just electricity. Something really simple. Electricity is the thing. If we are a brand, we want people to have a strong opinion on us. The positive answers are here. They're okay, reliable, fair, good, okay, good value, value for money, fair customer focus, but there's no feeling in it. If you want to build a brand, we have to have a feeling in it. If you look at the negative answers, first then we get feelings. You can read some, what does this say here, for example? I mean, first then we have consumers have feelings about us. And if you want to build a brand, we want to build in a feeling, and that's basically the case. And you build a brand like this. You go through emotions and rationality. The utilities are really good here, but they are really bad here. But if you want to be the Tesla of the future, or the Apple, or whatever good brands, they have to know the game and stay in business. So, that's my 10 cents for you today.
Thank you, Friedrich. Any questions for Friedrich? No? Well, I have to say I really appreciate this presentation because it's quite true. You need to understand, it doesn't matter the sector, you need to understand your consumer and to be able to sell your brand and sell yourself as well. There has been a lot of talk these days about like your personal brand, and I think when when talking about energy issues and the transition and so on, this topic is quite relevant. So I have a couple of suggestions for the audience, because we have a good crowd right now. And in the schedule, we were supposed to go on a break, but I would suggest to just continue with our last speaker, because we had one cancellation. She has promised me that her presentation is not too long, but it's very interesting. Then we go to the panel, so we all make it in time for the beers at the Belgian Pavilion. Are you okay with this? Say yes, raise your hand. Yeah? Good. So we are all ready for beer then. Nice. So last but not least, I would like to present Virginia Gomez, one of my colleagues, and she'll be talking about a project that we just finished with the European Commission. It's the Smart Readiness Indicator. So in this journey this afternoon, we have gone through free regulation zones, standards, understanding your consumer, but now from the European perspective, when trying to implement something in 28 different member states, you face different challenges. So please welcome Virginia.
Thank you, Tatiana, for the introduction. Yes, here we are again. So this is a study, a report we did at Energyville. We finished recently in August, and it's a supporting study on how to implement more legislation, and it's related to the Smart Readiness Indicator for buildings. So this is the outline of the presentations. I will keep it, the introduction, I will keep it brief, but I will present to you what the Smart Readiness Indicator is, what it means, what are the expected impacts and benefits. So that's why the Commission decided to do a study on the implementation. And then I will present the results of our technical study on our proposed calculation methodology, and I will present to you some application examples and the first impact assessment calculations. So let's start. So, as I said, this is the conclusions of the first technical study to support the implementation of the Smart Readiness Indicator. The main goal was to support the discussion process, the legislative discussion process. This is a report I'm presenting on behalf of all my colleagues, so it was done in collaboration with Vito, Ecofis, White, Strategic Efficiency, and Office. You can find here the link to the final report. It's an extensive report of 288 pages, but don't worry, there is an executive summary of 22 pages in case you don't have the time to go through the full report. So what is the Smart Readiness Indicator? So it's an indicator that it's meant to provide information on the smart readiness for the building. And what do we mean with that? So what we consider that a building is smart ready when it's able to interact with their occupants, it's able to interact with the energy grids, and has a capability for a more efficient operation. And of course, it has implemented some smart technologies, some ICT solutions that will make that the building as a whole performs better. So the expected implementation benefits are very clear. When we have a smart, ready building, when we have it that it can communicate with the consumer, it can communicate with the energy grid, then we have, of course, a greater uptake of smart technologies. So this means larger energy savings in a most cost-effective way, and of course it will improve the indoor comfort of the building for the occupants. Of course, this is a cornerstone for the future energy systems, where we have a larger share of renewables, and we will make full use of the demand-side flexibility. So the revision of the Energy Performance Buildings Directive already requires a voluntary, so it may seem a contradiction, but this is how it's stated now. It requires a voluntary European scheme for rating the smart readiness of buildings. This indicator has also other interlinkages with other directives and other legislation, especially related to the digital single market policy. So that's a bit the framework of the scene where we are. And I will introduce to you now the proposed smart readiness calculation methodology. So it's a very simple multi-criteria assessment method where the result is a percentage. So it's an SRI score which measures the distance to the maximal smart readiness potential of that particular building that you are assessing at the moment. So it follows three simple steps. So in the first step, you determine what is the individual smart ready services that are present in the building. Then you assess the impact score of those services according to the impact criteria. Don't worry, I will give more details afterwards about this. And finally, you weight the impacts on the overall score using these multi-criteria assessment methods. So these are the 10 domains where the services are listed to. So it goes from heating, cooling, domestic hot water, controlled ventilation, lighting, dynamic building envelope, on-site renewable energy generation, demand-side management, electric vehicle charging, and monitoring and control. So actually we divided these 10 domains that you can see here on the screen, and for each domain we listed a number of services. So here we have an example for the electric vehicles. You have the services of charging capacity, charging grid balancing, charging information and connectivity, and so forth. And for each of the service, you assess the functionality level. In the sense, is it present in there? What is the different level 1, 2, 3, the low charging capacity, medium, and high? And you assign an ordinal score to each of these functionality levels following the impact scores. So we have 8 categories impact scores that are related to the energy savings on sites, to the flexibility for the grid and storage, self-generation, comfort of the building, convenience, well-being and health, maintenance and fault prediction, and information to occupants. So usually you will look at the standards to base the assessment of the systems that are available at the building. So in an initial list of services that we had, we listed 112 services. But not all of them were equally visible for the inclusion in an SRI assessment, or there were standards were not ready to be included directly, or actually the effort to evaluate in this service was not worth the assessment effort was not worth the impact on the smartness in the building. So therefore we streamlined to a really actionable impact smart services, and now we reduce it to 52 services which have the highest expected benefits when it talks about smartness in a building. It follows the EPBD scores, which is also important since this indicator will be linked to the EPBD, and it has the highest potential for practical assessment on site. So we will see later on that the number of services can still be reduced when you are assessing a building. I'm aware this may sound a bit confusing, so I think the best to clarify is to see some application examples, how you can really use this methodology. And I will show you 2 examples. One is an office building and another one is a residential building. So the office building is one that already Johan presented. It's our Energiville building in Genk, pretty new building where it's used as an office and a laboratory space for 250 researchers, and it's actually meant as a living lab. So these are the 5 steps that you should follow to implement the methodology. you first do a triage on which smart services are relevant for this building, in this case for this Energyville office building. Then you assess the functionality level of each of the services, and afterwards you do the calculations, counting the impact scores and applying weighting factors. You then have to calculate what is the maximum obtainable score if all the services will have the maximum functionality available. And at the last step, you normalize to our SRI score. So let's do the 5 steps. We did look at all the services that were in the Energyville office building, and actually we only had to analyze or to assess 44 services that were still relevant. This is actually quite a high number. Most of the buildings will have a lower number, but this is because it's a living lab, so there are a lot of systems available in this building. And afterwards, for each of these 44 services, you will assess the functionality level of each of these services. Here we have an example for lighting, and we have functionality level 0. There is only manual on or off switch. Functionality level 1, it's the manual on-off switch plus additional sweeping extinction signal. Functionality level 2, that's actually our case. We have an automatic detection, so auto on, dimmed, or auto off. You can go to functionality level 3 with automatic detection, manual on or off. And for this case, functionality level 4 doesn't exist. Just for your information, the inspection time is also something we took into account when designing the methodology, because you cannot have a very complex calculation methodology that will not be practical afterwards for the implementation, since there will not be a market uptake if it takes too long or is too expensive to calculate the indicator. So in this case, it took 65 minutes, and we had the marvelous collaboration of our facility manager. Was mainly a visual inspection, and not all the rooms were assessed individually. So here you have some pictures of the various services that are present. You can see you have our rooftop PV, electrical charging, several heating systems, and the managing and control. This is the back of our facility manager. So afterwards, we did the assessments, and we did calculate for the 8 categories of the impact criteria that we saw before, from energy flexibility to the information to occupants. We calculated our ordinal impact score. We normalized it considering the maximum obtainable score for the case study building, and we have the relative score. Afterwards, the overall score is not calculated as a median or a simply average of the relative scores. You can apply weighting factors, because of course, for some of the impact criteria, it's not the same weight that you score high on energy than that you score high on convenience. We do not enter into the discussion of really calculating these weighting factors, because that's something that needs to be discussed at policy level, and it may vary per member state depending on the priorities that they have at implementation time. So here in this case, the overall score that we calculated is 77%, which may seem a bit low when you consider that it's high standard living lab office building. But this also gives an indication that there is still room for improvement, and there is still some actions to be taken to make this building smart. And here, one of the criteria that penalized the building the most is that there was no information to occupants. So there is a lot of information of what is going on in the building, but it's not sent back to the occupant of the building. So we did also the same for a residential building. This is a single family house in Manchester in the UK. It's quite a big house of 250 square meters with 6 bedrooms, 3 bathrooms, office, utility room, and 2 living room areas. And it's partly renovated. You can find all the details of the description of the house in the report. So again, we went through the 5 steps. We first analyzed which are the services that are relevant for this building. In this case, we have a lower number, which is logic for a residential type of building. And we got 23 services that are still relevant. We assessed for each of them the functionality level. In this case, it was again a visual inspection with it took 30 minutes, which is actually half of the time that it took for the living lab office building, taking into account that we have all the documentation available. Otherwise, it will take a bit longer. It will take around 47 minutes without the relevant documents. So here, of course, the interaction with the household, with the owner, it's important to discuss with him what services and what is installed already in the building. So then we did the impact score and applied some weightings. Here you see the 10 domains and the 8 impact score categories. Of course, you see some of them are 0. These are because the services were not relevant for this house. And afterwards, we calculate what is the maximum available score, and we normalize the SRI score to a 53% potential of smartness impact for this building. So also we did some small, the start or the initial impact assessment of the SRI. In a first step, we had to, of course, do an estimation of the evolution of the building stock at the European level, which is already a challenging task on itself. So there was a modeling of the evolution within the framework of the revised EPBD, so related to new buildings, demolition, and retrofits. Then we considered the energy efficiency measures that apply to the building shell and the heating, ventilation, and the air conditioning systems. We focus on 5 geographical areas across the European Union, and we follow 2 building sector pathways. So in the first one, we looked at the scenario where the revision of the EPBD is implemented without any additional measurements. And in the second pathway, we estimated that there was some more ambitious implementation than the EPBD strictly requires. In the second step, we had to estimate the effects of the uptake of the smart readiness technologies and the smart readiness indicator itself. And we package it in 3 different packages, depending whether the building has heating system, cooling system, or both. And we calculated from there 3 different scenarios. So the business as usual will be when there is no SRI implemented. The moderate scenario is when the SRI is considered voluntary, as it is the case in the current EPBD revision. And the high implementation scenario is, well, the SRI will be still voluntary, but it still has some strong support from the member states at the moment of the implementation. Of course, the effect of the SRI is partially dependent on the level of uptake of the SRI, the Smart Readiness Indicator, and on the supporting policies of the member states. And that's, that's a decision that each member state has to take. And of course, the impact of the SRI and the smart readiness, the smart readiness technologies uptake, it's also time dependent. So the longer the SRI has been in place, of course, the larger the impact. So I invite you all to read all the assumptions, because there are many assumptions and a hypothesis behind the calculations, and they are all outlined in the report. But just to give you a flavor of the result, so that's the estimations for the case of the high ambition scenario. A savings of about 400 terawatt hours could be on final thermal energy savings could be achieved. So I will just wrap up the presentation with small notes on the conclusions. That the smart readiness indicators shall provide information on the technical readiness of the building, as I said, to interact with the occupants, with the grid, and through the use, of course, of ICT technologies. And it should become, or is expected to become, a cost-effective measure that can raise awareness about the benefits of these smart technologies and ICT towards the consumers. And it should motivate consumers to accelerate the investment in the smart buildings and support the uptake of this type of technologies in the building sector. And of course, this was just the first technical study. There is a follow-up study that should start soon. So in that one, there will be really the implementation at member state level estimated and studied more in depth. And yeah, that was all I wanted to tell you. Thank you very much for your attention.
Thank you, Virginia, for the very interesting presentation. So now it's, let me check on the time. It's 3:30. Is there any questions? So as I proposed before Virginia's presentation, we can move to the panel, and I will invite our speakers to sit in the front. Friedrich. We're missing one. Yes. So you have heard these 4 presentations, and I think each speaker has been very, very excited and has done a very good job in advocating for what they believe in. So we went from self-regulation, no regulation, understand your consumer, to macro-regulation at the European level. I will start with one first question, and it's very general. If you have to pinpoint just one thing that, in your presentation, or in your view, that hinders the uptake of new technologies, as you have presented. For instance, if in your case you presented, Friedrich, you talked about a low regulation zone. So what would be the one thing hindering the uptake of new technologies in a low regulation zone? I'm trying to put you against your own position at the moment. Just one.
Do you hear me?
Yeah.
Okay. Actually, the thing which is hindering most is not really regulation, it's tariffs.
Which are given by?
The fact that 1/3 of the energy bill in Flanders is energy, electricity or heat, and the other 2/3 are taxes and just let's say some other things that are put onto the electricity bill don't help the business case. And there we are confronted with also the difference between, on one hand, the regulator, which we didn't talk about too much yet, but tariffs in Flanders are set by the regulator, and the regulations are made by the policymaker. And those two don't really are working together all the time. Just to give you an idea, the Flemish people here know that we are trying to introduce a digital meter. Digital meter is regulation, but we are having now the thing that the compensation scheme for solar roof PV will be impacted by that digital meter. The policymaker says there will be no impact, and the regulator says we are going to change the tariff so that there is an impact. And as a result of that, we see that there is no investment in solar roof PV anymore. But that's about tariffs. And tariffs set by the regulator, not about regulations set by the policymaker, which makes it kind of difficult.
So you're saying if there's no tariffs, then there will be no hindrances?
There will always be tariffs, but tariffs can be...
Imagine in a world with no tariffs. That's where I'm trying to put you. Like
that's what we call communism. I don't think we want to go to that kind of thing. But what there is that we do put a lot of taxes on top of the electricity bill instead of letting the market play. And I think that if we would if we would have said by the beginning that when we put highway roads, that we are going to tarify every time a user uses that road, there would never be highways. But that's what we are trying to do with our current energy system, which makes it difficult to get new business models running.
Liberalize it a little. Liberalize it a little bit more, you mean?
Yeah, and make it, put it more in general taxes instead of in electricity systems.
Okay, Virginia, if you would have to say about European regulation, what would be the one thing that hinders the uptake of the smart readiness indicator at the European level, coming from the European Commission?
Well, currently, it's actually the European regulation.
There you go.
Because against the initial prognosis, it has been the smart readiness indicator has been included as voluntary, which brings a lot of how every member state is going to, if at all, going to implement the smart readiness indicator at their country. So actually, it's not the ideal situation right now.
But that's the situation in general at the European Union. It's when you have a European regulation, it's just a mandate to the member states to regulate.
Yeah, correct. But for this case, it's voluntary. So the regulation says that it's voluntary. So,
but nevertheless, it has to be implemented.
Yeah, you see the point, huh?
Very challenging.
Yeah.
What about you, Johan?
Oh, this is. Oh, okay, good. You see, me and wireless technology doesn't go well. Huh? So now, I talked about something that is linked to mainly technological innovation. Now, if you're in a phase of innovation, the least you need is a lot of regulation because you want to have freedom to operate and try new things. So you want to have an open market. But that's typical if you introduce new technologies like the video recorders and cell phones. You see lots of competition between technologies. But you know, at some point you will end with more quasi-monopolies, like we have in the AC grid, or we have the 4G network now. And that is when a lot of new entrants come and they can become interoperable with that quasi-monopolistic technology. The problem is when you switch from phase one to the end phase. And that's where regulation can help. Now, unfortunately, regulation, typically European regulation, follows the dogma of technology neutrality. Yeah, you see that also in the choice towards more sustainable energy. They always keep all options open. And maybe that's not a good thing to do all the time. Maybe you should once in a while favor certain technologies, give them a chance. Now, if they don't make it, kill them also. Maybe we need that now in a few sectors, like in storage, like in AC versus DC, and so on. And the fact that that dogma of technology neutrality keeps on hanging around all the time is for the moment a hindrance, I'm afraid.
But you advocate very actively on the need of almost global standardization.
Yeah, but that's technical standardization.
Yes, it is technical. Yeah. But one could argue as well that these global standardization codes or mandates or whatever you want to put it could also hinder innovation for newcomers.
Yeah. That's true, but there's some base. It's like in legal frameworks. You have some constitution, and then you have laws, and then you have decrees. Mm-hmm. You need a constitution, and that says everything should be safe. and everything should be efficient, yeah? And don't waste any materials and those kind of things. That's what we need. And the stuff above it, yeah, the more detailed it becomes, the less you need it in practice. But we're still lacking the constitution in some new technologies. That is the problem.
Within the standardization world,
yeah, very simple things like what are sort of unified voltages so that things can be connected to each other. Something that's very obvious, but still, look, we live in United Europe. Try to fit one plug of a country in a socket of another country. That's where we are in AC after 120 years. So I hope we do better in DC.
Friedrich, so for you, I mean, the question was in general for each speaker to find what in the topic that you advocate on, what is it hindering. In your case, I see it because I see it in a way that you advocate for branding and good branding to understand your consumer and so on. Would one be able, or I think one can be able to say that when there's too much branding, or you go to greenwashing or something like that, but do you see it as like that as well? What could be the hindering point of your advocacy?
You bring up a good point, maybe. The greenwashing thing is actual and is real because there has been a lot of greenwashing. And because it's just an opaque concept, green is, so then you can basically, fool customers. But, back to your question, it's not really, I don't really have an opinion on what's hindering, but I think that in general, if you make regulations, you do it for the greater good, of course. And you don't do it because consumers ask for it, you do it for a greater cause. But what, marketing can do, it can help people to accept various regulations and policies and help them to accept how it makes their life easier, how it makes their life better and the society better. That's a communication aspect. It's how you talk about it. But sometimes consumers don't know what's best for them. It's a famous story, for example, that when before the times of cars, if a typical consumer would have been asked, what kind of a vehicle they would like a really fast horse wagon because they didn't know the cars would exist. So we have to push for regulations. We have to push for these things that the consumers like, but we have to help them to accept it. That's what I would say about it.
Okay. Does anybody in the public have any reactions to this, to the first answers? I'll be the only one asking questions here. I will need a little bit of help. Okay. All of you.
May I ask a question? May I ask you guys?
Well,
because I'm talking about something that's totally different, and some people agree with me, some people don't. Where do you stand in this, in terms of policies and regulations? I mean, does it matter to have a marketing guy commenting on it?
There's another one.
Well, I think it's one of the aspects we often forget, and I think it's very necessary to really engage the consumer and engage the customer, and also that man in between. If we take, for example, a look at the people who I trust when it comes to energy, that's the installation guy who comes by and say, okay, you need to have that thermal system. And if you're able to convince him one way or another that it's for him convenient to install the new heat pump and the new solar panel and whatever, he will really realize that uptake, which has nothing to do with regulation, but just with how are you able to convince all that intermediary levels that are really part of that bringing technology to the market scheme, and which are often very conservative. If you take a look at our situation, somebody who has been installing, let's say, gas boilers for ages, why should he change to installing a heat pump or a CHP? He doesn't know anything about it. When it's broke, he cannot repair it. So why should he invest? Why should he tell me, okay, you should invest in a heat pump? So that it's perhaps going even a little bit further than just marketing. It's marketing not only the end consumer, it's not only engaging the end consumer, it's engaging the whole supply chain of such an energy system. And that's a real challenge.
Yeah, I also wanted to comment on this point because actually that was one of the discussions we had during developing the methodology of the smart readiness indicator. the overall goal is that the consumer understands it and sees the possibilities that he or she has at their home, and that they are motivated to take the step and make the decision of, I will install this and this and this system. Now, you go to them and you present them a percentage. Well, at the end it was only 1%, but first we started with the full package of numbers and percentages and impact scores, and yeah, we already concluded that was not actually feasible. You cannot communicate like this to the consumer. You will simply overwhelm him with numbers, and that's why we had only one overall percentage. But still, the discussion or the question mark remains: is this enough to convince the consumer to make the step of investing on smart technologies, which is the overall aim of the indicator? And I don't think we are there yet, because actually one of the tasks will be for the assessor or the person that will calculate actually and will be with the homeowner doing the inspection at home. He should be able to communicate and to discuss with the homeowner. So that's a step even farther on that.
Okay, branding. Here's the engineer on branding. No, well, first of all, I like communication. And for me, branding is just part of communication to a very broad audience. And with that comes the price that you pay, is that you have to simplify a lot of things. But that's no problem. I think we should, to quote Richard Feynman, we should all be able to do that. Otherwise, you're doing something wrong. Huh? But also with branding, I think they should know when to stop. Sometimes it becomes a self-fulfilling prophecy. I think I better explain that with an example we had. Not so long ago, we were talking to a company that needed some help with an innovation, and it was something at a problem with solar energy. And the company was at a certain moment asking us, can you put in blockchain? Why would you need blockchain? No, we want to put in blockchain because it will solve everything, make life easier. And in the end, the project crashed because they wouldn't believe that blockchain wouldn't solve everything in the digital world. So that's, I think, a case where some of these brands, like blockchain or the word smart or green, or probably there are other examples, they are sometimes living a life on their own, and you should also find a way to stop it, then I think.
No, I agree. Sometimes we have a trend in like clothing and eating, and also the Internet of Things, smart and all that, become buzzwords, but they live on their own. But just to pick up, I don't want to hijack this, because you talked about engineers. My task, I work for utilities. I deal with engineers most of the time, but they are binary, on, off, black, white. So it's hard. So they only use, the right side of the brain. So I teach them to use, both hemispheres. So just to pick that up.
I feel you. I work in a building full of engineers without being one of them.
Yeah.
Yes.
But when they understand you, they are the best in the world, actually. When they're on the, yeah.
Okay. So one of the favorite things, my favorite things about the European Utility Week and these hub sessions is that we have very cool microphones that you can throw. So this might motivate you to ask questions. We have one question to the public. So there we go.
Does it work though?
Yeah.
Is it working?
Yeah, it is working.
Oh, good, good. Well, hi there. I'm Nigel Orchard from Pilot Systems in London.
You need to speak a little bit loud. It works, but
to the white thing here?
Yeah.
So I'm Nigel Orchard from Pilot Systems in London, and I'm in the unfortunate position of being in, for the last 15 years, smart meters in the UK. But I've been in the metering business for 35 years. And I just wanted to pick up on the whole regulation, standards. We need an infrastructure to support all this, but we need innovation as well. So we need, individual consortia, if you like, or companies to innovate. And so we need the interoperability. Now, I'm walking around this exhibition and I'm being told by all the stands, you use what we're doing. We've got the smart solution. And this might be a corporate, but I'm also walking around and I'm seeing standards kind of companies, open the G something or other, Open, DLMS, whatever. You know, there are about 7 or 8 of these standards companies. Well, I mean, what are these guys doing? Now, in the UK, we've been trying to do smart meters now for 16 years. Now, do put your hand up and interrupt, because this isn't a question, this is more provocation, okay, to sort of kind of get you. We've been trying to roll out smart meters for 16 years. We still haven't achieved it. We've appointed Capita to actually do the data collection for us. They were appointed in 2013, and we've been paying them £100 million a year, and they still have not delivered. British Gas Centrica have been pushing smart meters probably for the last 10 years, and now have probably almost got 50% of the market. But if you change your energy supplier, they don't work anymore. And so these leased assets, smart leased assets, smart leasing costs are still being paid for over, say, a 10-year period, but the asset has become dumb. And so if you want to continue having a smart meter, your new supplier will fit one for you, and you will then incur a second smart metering leasing costs. And there are people now who are onto their 3rd or their 4th. Now, obviously, they don't see it because it's socialized across the industry. But we're complaining in the UK about high energy costs. And this is one of the reasons. We're in a position where we don't, accountability, responsibility for delivery isn't the same as where the money is coming from. The money is coming from the consumer, and no one's accountable for the expenditure of that money. So really, I think where I'm coming from and where I'll stop is that you need to establish a framework, and might I just suggest something a bit like the internet, IP, which is low enough level and generic that you don't tread on anybody's toes by implementing. And then you let everybody get on with it, and they know that what they've got will work because they can add content and use that infrastructure to provide the value. But you then achieve your 3 I's, your innovation, your interoperability, and your infrastructure. And to go to your point, sir, about what the customer wants and telling the customer what he wants. You know, if you buy a car or a sound system, it's got amazing number of knobs and bells and whistles on it that the consumer will only use probably 10 to 20%. But they'll all probably use a slightly different 10 to 20%. And I think our standards committees will look at what is the biggest 10 to 20% that people will choose, and will standardize on that. Well, that's fine for today, but for tomorrow, it's going to be different. And if you're trying to innovate with a standards company, you'll fail, because tomorrow that won't be 20%, it'll be 18%. And next year it'll be 16%. And the next year it'll be 14%. And how do you then add? You have to do it by, excuse me, getting competitors to agree with each other about what their unique features are going to be. I think I'll stop there because I'd love to hear, you're all making funny faces at me, and the chair is delightfully giggling. So I just welcome some comment back.
Johan, do you want to reply?
I want to give 2 comments.
Okay.
Short comment. What you describe as on a smart meter is a stupid meter. The word smart just the brand smart, created wrong expectations. I just want to poke him. But you also were talking about open standards and these kind of things. Now, there are several types of open standards. In my opinion, there are 3 types of open standards. One type is actually a standard coming from a dominant company, and that is so dominant that it says, okay, now you can have all my patents. Whatever I do, it will create more business. think of Tesla that says, my patents are now for free because everybody will just copy us. That's one kind of open regulation standardization. And then you've got independent bodies developing it. And there are bodies that, let's say that you have open standards that are developed by enthusiasts, naive people. Some people may call them scientists also, that do it in their free time and then throw it on the internet. And sometimes it works. You have some examples in computer science that are like that. But honestly, in energy business, it's so complicated and there's so many liability issues also that is probably not the way to go, to just try and blow up a few things. We cannot have the equivalent of a computer crash. So the third kind of open standardization is actually standardization that's developed by neutral bodies, research institutes, standardization institutes like NIST in the US, for instance. But the problem is they have to be on time with this and they need to get funding on time for it. And I speak from experience. I try to get funding to work on codes and standards, like for what I have proposed here. And honestly, it's very difficult because the first question you get these days, if you ask for funding for things like this, is what is your valorization model? Afterwards, how are you going to get money out of it? I said, no, it's for society. I want to make an impact on society. Yeah, then you're not eligible. That's unfortunately the answer that you get. So we're in a catch-22 somehow, I'm afraid. Okay, now, Frederic or
I think
Virginia.
it relates what he was saying about the dumb smart meters. It relates a lot with what you mentioned before on this sort of constitution of things. But I also want to be a little bit provocative when you say that if you ask for funding and say it's for society, and then it doesn't have a valorization number back, I would argue that everything that is for society should have a valorization on this.
Yeah, but not the kind of valorization that these days you have to prove. Eh? So I know project, let's say certain grants that get evaluated first on their valorization potential and then they check whether it's scientifically sound. That is so wrong these days.
Yeah,
so
that I agree with. But I as I said, I would argue that everything that is for society should be self-sustained financially in the future. And that should come within the research that you are
But then we're talking of on what time scale.
Exactly.
That's the dilemma of fundamental science.
Yes.
Yep.
Yes. Okay. Any other questions to throw around this? Do you want to reply?
If I perhaps may also do some reaction. What I see is that a lot of things go wrong when there are a lot of stakes. And that's typically something which is inside the energy business. There are a lot of stakes at play, and that makes that people who are not made for collaboration also don't collaborate, which makes it very, very difficult. When you go to psychologists, they will tell you that our brain still is into system one thinking, as they call it, which is we are always hunting and we are always opposing. And it's only when you go past that brain that you go into a system two when you go to cooperation. And cooperation is not easy at all. And whenever the stakes rise, you get more and more into that opposing instead of collaboration thinking. It's also one of the reasons we as cluster organizations exist, because otherwise we're always opposing. So when you make that reflection to the internet, the IETF standards, Internet Engineering Task Force, the request for comments of ages ago, RFCs, there was nothing at stake at that moment. It were indeed a bunch of engineers coming together and having fun, and okay, we are going to make a standard along the way. And actually, that we are able to send email and pretend that we are somebody else, like we used to do when we were both young at the same university, that we were sending emails on behalf of Professor, I don't know, whoever. Yeah, nobody cared. So the RFC also didn't care about the fact that we are trying to impersonate some other people, unless a professor who felt a little bit annoyed because he was never sending those kind of messages, and actually we couldn't even trace who had sent that message. When we entered the computer rooms, the first thing we need to do was close all network ports down, because otherwise I knew that he would use my screen to perform to have some ugly pictures on my screen. Now we don't accept that anymore. which makes the stakes a lot higher and makes it a damn difficult job to make standards. Especially since all the countries have their own different views and want to really have their view put through. If you take a look at France and you go to take a look at the digital or the smart meter over there, it's an entirely different system as the one that we have in Netherlands. And we, in Flanders, we're trying to use the one of the Netherlands standard. And our Walloon people, which are only a few kilometers ago, they will go for the French standard. So even in one country, we do have the same problem. And people are having problems to put them on the market just of tarification problems. So I can bear with you. You're not the only one with difficulties to introduce smart metering or digital metering. But when the stakes tend to rise, I didn't find any good solution to it yet, to be honest.
Okay. Do you want to reply? Okay.
Thank you very much. Thank you very. Can you hear me? Yeah. Thank you very much. That was very helpful, particularly this psychological bit and the fun about the university and stuff. I did like what you said about valuization, because there must always be valuization. There must always be valuization, because otherwise you wouldn't do it.
Yeah,
now, it might just be your personal ambition, but generally I think valuization to a society is something that, and I didn't vote for Brexit. I'm not a Brexiter. My wife's a Finn. She's from Finland.
This guy deserves an applause, I think.
As far as I'm concerned, this is the biggest mistake that the UK are making. But, you know, we're now not in a position to assess whether what we do is going to help society anymore, because we haven't got a hold on what society is. You know, if it's Donald Trump, then it's, well, we'll just, you know, keep our coal workers in work. If it's, you know, China, it's we'll make sure our state remains, you know, as it is. So that the agendas are different, and to a certain extent, it's sort of identifying what that social that social delivery is, and seeing how it can be implemented without affecting what else is around it.
Okay, you want to reply, Frederick?
It's called democracy. And democracy is never very fast in decision taking. Did it fail? I don't know. I think there was yeah. I think there was quite some, let's say, misinformation into the market, to call it like that.
I would ask the audience and the panelists to remain apolitical a little bit. Let's. Thank you for voting to stay, but yes, democracy is not perfect, but let's not become North Korean either.
If I may tap onto the remark that Johan made about valorization, I do see that a lot of how we translate valorization at this moment in Europe is really economic valorization, and it's on turnover, it's on added employment, it's on that kind of economic, let's say, leverage, which is not always that good when you take a look at transition thinking. We are inside a transition phase, and at least in a transition phase, it's when you are asked to make, let's say, predictions. It's like, I don't know what will happen. I have no clue. And if there would have been somebody who was able to predict that the highways would be used as they are at this moment, I think they would have, It was IBM who said that there would be room for, let's say, 2 computers at world level. So the world is built on misinterpretations when it comes to valorization. So I think we should leave that emphasis on valorization to some extent and look more at let's say, the higher purpose to take that also into account. But it's very difficult, at least in Flanders. And I think also on the European level.
I think both Johan and Virginia want to reply to this. So ladies first.
Okay, thanks.
Yeah.
And I fully agree with you, Frederick. I think when something is designed for society by default, it has some value and some valorization, and the challenge is how to calculate and how to put a number on it. And when we are focusing on, exactly as you mentioned, on economical value, maybe it is very challenging to calculate that and to calculate it in an accurate way. When you do a business plan, it's wrong by default. In the first moment that you put it on paper, you know that these are numbers, but they will not be true. So that's the challenging thing also, how to decide where to put the money, the public money on. How do you then, if you cannot calculate in an accurate way the valorization, how would you judge that? Johan?
Yeah, this is a difficult one. There the magic word is impact. Yeah? That's something we had to learn to write about. Economic impact. Yeah, but in other projects you have to write impact as a whole. No, it's important. You have to think about what you do, whether you do innovation in a company or whether you do something in a research institute. Yeah, let me be the university guy here for a second. Not everything should be immediately be valorized. Once in a while it's good to be curious. Otherwise we would never have discovered quantum mechanics. And 150 years later we made solar panels with that. So once in a while you have to come up with things, do them, put them in a paper, and maybe 3 generations later they find a good cause for it. So not everything should be economically valorized immediately, I think. So, but it's always hard when you're an engineer and you claim to be doing scientific research, because an engineer is applied science, so by definition not real science, according to some people. So if we say we do something fundamentally new, they start laughing. Usually people who get the funding from, who are real fundamental scientists, who get funding from those kind of research funds. And there's something we have to watch out for, that we do not go all the way with engineering research into that corner of only economic valorization. Also, let us be creative once in a while and try crazy things for the later generations.
Do you want to reply to this, Frederick?
No, I don't really have a comment on it, but you said you were, I'm a social scientist, so you can imagine when people look at me. So I'm on the bottom of the food chain here.
I do have one comment before I go to my next question. When you say about valorization, and we talked about this, well, I started this presentation or the introduction saying what the challenges are posed to this generation and stay below the 1.5 degree. And when in this in the energy transition framework, sort of it, would you think that, or would you agree with, when talking about valorization, we can transpose it into CO tons saved, increase level of health, access to health, or like less sick people due to, I don't know, air pollution, carbon emissions, and so on? That, if I think of the citizen as a low tax, very high taxpayer Belgian resident, I would like to see my taxes, or the valorization of my taxes, in a better and an improvement of my quality of living. So better transport, cleaner energy systems, less visits to the doctors because of my asthma attacks and so on. Would that be a valorization, a practice that could be accepted?
You can always try to come up with a lot of objective criteria and then use them in a subjective way. That's the problem. We do that all the time. Because there are so many objectives we want to reach for so many people, and everybody valorizes them differently, and there's the problem in the end. Because you like health more than, for instance, I don't know, easy mobility. But for other people, it may be the other way around. So there's the problem. As the sociologist next to me will say that everybody has a different value to all these parameters.
I was thinking of a case that I heard last year in the Netherlands, neighboring country to us. So they had a big fund for renovating dwellings, and they identified that one of the drivers for renovation was not actually energy savings, but health, because the government saves money by giving people money to renovate on health insurance. You have less. So I think that's a very practical and objective indicator on valorization for these kind of things. So that brings me to my, okay, Friede wants to reply to this.
Well, we had a presentation once in one of our events from a Danish guy who said that actually when you want to achieve that transition thinking, the real value is in what he called the NEBs, the non-energetic benefits, like health, like comfort, like those kind of things. And we should be able, if you want to achieve something, we should be able to quantify them one way or another. And they did really a hell of a job in order to quantify those parameters. And it works as long as you don't put objectives onto it, as long as you keep them without any cause, to call it like that. And I think that's also something in psychology. Whenever you set a target, you're trying to misuse the target in order to reach it. If you give me a KPI, you can make sure that I will reach that KPI. That's no problem.
Do you want to reply to this, Frederik? No? You're okay. Okay, is there any other questions for the public? No? So I'll go to my last question, because after all, this is the European Utility Week, and we're in the consumer centricity theater. So from your point of view and the topics you have presented, do you think utilities these days, what do you think it's the role of the utility understanding their new consumers or the consumers you are in touch with?
Which utility?
The utilities that you're working in, for instance, in your project within Flux 50.
Well, even a utility company has different doors, and it depends on which door you knock on, whether they're willing to cooperate or not.
I can use one of the examples that you used in your presentation. So you talked about this project, the project, and you mentioned something about energy efficiency in the hospital and how savings in a surgery room can be much higher than in a number of dwellings and so on. Do you think the utilities working with you or working within this project understand this consumer, or what do they have to do to understand this consumer better? You can think about it.
I can.
If you rephrase your question, can you ask your question again exactly like you asked?
Exactly as I asked.
Yes, because I want to, yeah.
Okay. So, because we're in the European Utility Week and we're in the consumer centricity theater, in your opinion and from your expertise, do you think utility, or what do you think is the role of a utility to understand their consumers or the new consumers of the future?
Yeah.
Young people, name it. Young people, hospitals, member states.
Well, I would turn this around a little bit, this question. Okay. I mean, they might not even have a role because someone else will be fulfilling their needs. I mean, if they have, it's not like they have to have a role to do something. If they want to stay alive, they have to adapt to the ways of the consumer. I mean, this is the case in the rest of the world, basically, and we are just left alone here. And this will change also for us. When I was writing my PhD, I looked a lot to telecoms, and remember this time when telecoms were like also, they owned us. But that's changing so fast, and we just don't know which party will, fulfill the needs of the future. And will it be Tesla? Or there was a research done that people were asked if they could buy Apple Energy. 70% said yes, they would buy Apple Energy. It's about brands, and someone else will do the job if they don't adapt to the consumer. That's what I would say.
I was actually looking for that answer, like even if they have a role, because that's something that we discussed. I think you were also part of the advisory group, and I think we were in the same group last year. We discussed this. Do the utilities these days actually have a role? And It was such a lively discussion. I wanted to bring it here. That was sort of my intention.
But if you then turn to the question, do they at this moment understand the consumer? I think it's no. I think it's one of those aspects where we do have a lot of green field before us. If you would reflect, for example, to the car manufacturing industry, they know their consumers far better as what an electricity or a utility company knows at this moment. And I have the impression, and this was also when it comes to the hospital, I think they do know it better as when it comes to the end consumer. Especially since there is a lot of difference coming on in that end consumer market, in that residential market with local production, and at this moment they don't know how to handle that. But that question is less dominant when you go to large industries, which are often not able to self-fulfill their needs based on, let's say, local small-scale production. But I do think that, yeah, in the end, they will need to adapt, but it will be a slow process. Also, the entry barrier for new market players into the field is quite high as a utility. There are a lot of legal requirements. You're not even, we are trying to get energy supply licenses, which are given in, let's say, France or UK, being recognized in Flanders. Well, at this moment, it's not yet the case. At this moment, you need to apply for a separate energy license in Flanders, even if you're able to operate energy wherever in Europe. So we are not liberalized as a market as it should be to let the market play, I think.
Yeah, I also agree that with the fact that they are not trying yet to understand the consumer, and one of the examples is for the Smart Readiness Indicator. It was an open process, consultative process, so we had several meetings with stakeholders, and sometimes we had more than 100 stakeholders in a room discussing the methodology and the context, and there was not a single utility within these 100 stakeholders, even though one of the expected impacts is on their benefits, on the interaction, higher interaction, use of flexibility and communication with the grids, just as an example.
Yeah, my comment on it is, do the utilities understand the consumers? Well, I think they hardly understand the possible products they want to sell. So if you look around here on this fair, the old style utilities that you can still find, they try to hide that you're selling electricity or gas. No, they sell you electric cars and charge points and solar panels and everything else. So I think this is just an exponent of a very bad trend that seems to be happening in the utility world these days. And I hope with statements I'm going to make, I can leave this fair alive. But I see a lot of trends towards what we saw happening in the banking system 10 years ago, where we have some old companies doing boring things that hardly make money, and that's bad banks, bad utilities, and then the fancy new stuff in fancy shiny companies that are having good market value. They get all the attention. But if we don't watch out, the old ones, the bad bank ones, they will disappear, and what happens then? Then parts of the system will collapse, I'm afraid. So.
Okay. Well, if there's any other question, raise your hand now or keep it to yourself. And if not, I would like to thank our panelists and presenters and ask for them for a round of applause. And also invite you, well, repeat the invitation that we got from Derek, to go to the Belgian pavilion. It's, where is it again? It's on the other side. B222, because it's beer time. So Belgian beer time. Thank you very much.